All right, so going through 7.1, walkthrough of the homework. If we have this left-hand side and we're trying to get to this right-hand side, I'm probably going to start off with the left because it's got more terms, and in a lot of these proofs, from our examples, we've seen that we're going from more terms to consolidating it down to one. That happens quite a few times. So if I've got more and I go to one, I really think that that's going to be the easier way to go because you have more to work with. So if we start with this side, one technique that we always know that's good to try is get everything in terms of sine and cosine. So I have memorized that this is this. And then every time I see sine, I'm going to rewrite it as sine over 1 if I want to really see it as a fraction. So now when I look at this, I see two fractions that needed to be added together to get to my eventual one term. I use a well-chosen one by multiplying it by sine over sine. When I do, sine times sine is sine squared. And so now I can subtract the numerators over the common denominator of sine. But then I have memorized that 1 minus sine squared is cosine squared. And now I'm thinking about where I'm trying to go. Okay, I'm here and I want to get here. Well, this has one cosine by itself, so I pull one out by itself, and what's left over? Oh, great, turns out to be exactly what I want. And you've now proven that the left-hand side, through a series of equals, is equal to the right-hand side. 4 or 3, you have this, and you want to get to this. Well, first off, notice that 2u is just some angle. And because these angles are the same, we can use our trig identities to do some work on it. So the main thing is these angles have to be exactly the same before we start combining things. So I know that secant squared minus 1 is just tangent squared, and I'm trying to get down to just sine squared. So this gives me this. Well, then at that point, I'm happy because at least I've got one little piece instead of this subtraction on the top. And then I know I can change everything in terms of sine and cosine. So tan is sine over cosine, and secant is 1 over cosine. Well, then I have a fraction divided by a fraction, so I keep this, I change this to multiplication, and I flip that. Get this. Wonderfully, these cancel out and I get sine squared. So I've shown through a series of equals that this is equal to this. Now, if you're trying to get from this to this, again, I'm going to try and I'm going to use this side first because there's more stuff to work with. So in the back of my mind, I always think, okay, I'm wanting to go towards cotangent. Well, when I see this, I know that 1 plus tangent squared is secant squared. And then I can rewrite everything in terms of sine and cosine. So cosecant is 1 over sine, so cosecant squared is 1 over sine squared. And secant is 1 over cosine, so secant squared is 1 over cosine squared. This divided by this is just another keep, change to multiplication, and flip, and I end up getting exactly what I want because cosine over sine is going to give me my cotangent that got squared. So much of this is having your identities memorized, as you can see. For 7, I have this plus this. Well, it's two fractions, and they want to show that it's equal to this. So if I have a bunch of ugly stuff is equal to something small, I'm definitely going to start with a bunch of ugly stuff, hoping I can condense these two terms into one term. So how do I take two terms and make them into one term? Well, I get a common denominator. So I look at this denominator and this one and say, okay, well, this one is missing 1 plus cosine, so I multiply it by this well-chosen one. And I say that this is missing cosine, so I multiply this term by this well-chosen one. When you do, this is the common denominator, and this is the common denominator, so I can just add their numerators over the common denominator. Well, sine times sine is just sine squared. And then this is a binomial times a binomial. So 1 times 1 is 1. 1 times cosine is cosine. Cosine times 1 is another cosine, that's why I have 2. And then cosine times cosine is cosine squared. So now I've added all the numerators over the denominator, the common denominator, and I recognize cosine squared plus sine squared as long as they are the same angle. Cosine squared plus sine squared is always equal to 1. So now 1 plus 1 is dos. So now I have 2 plus 2 cosine 3t. I know, then I kind of look ahead at where I'm going. I want to get cosecant, and I know that's 1 over sine. So I probably want to keep this, but I want this to go away. So since that's 1 plus cosine, I look up here and go, well, that's close. If I factor out a 2, then what's left is my 1 plus cosine. So now my 1 plus cosines cancel out. I'm left with 2 over sine, but 1 over sine is cosecant, so 2 over sine is 2 cosecant, and you're done. Look at 11. So I want to go from this ugly stuff to one term. Well, I think I'm going to start with the ugly stuff. First, I'm just going to multiply my two binomials. That times that gives me this. This times 1 gives me that. Tan times this gives me tan this. And tan times 1 just gives me a tan. So now I have 4 terms, which I want to get into one term. Well, now I remember that I can get everything in terms of sine and cosine by my memorized identities, which gives me this. But then I noticed that I now have 1, 2, 3, 4 terms, all separated by plus or minus. So this 1 over cosine, I multiply by sine over sine. So actually what I do is first just really make sure that you can see. It's not going to let me erase that. Let me put some white out in there. So if I put some white out in there, now I want you to really take a second and look at those 4 terms. So this has its denominator as cosine sine, and so does this. So if I want a common denominator, I have to hit this with sine over sine, and I have to hit this with sine over sine. And when I do, they now all have the common denominator, cosine sine. And so I just add all the numerators over the common denominator. Well, that is 1. This is sine. This is negative sine. And this is negative sine squared. So these cancel out beautifully, give me 1 minus sine squared. But I have memorized that that's cosine squared. These cancel out and give me just cosine over sine, which is what I want, cotangent. And there was much rejoicing. So as always, we see that this oftentimes starts off as a problem, but now since we've seen it, if it was on a high-stakes test, it would be an exercise. So we have 35 and 44, and then we're done. So if we look at 35, we are wanting to get these fractions into 2 cosecant. So what I would do is I'd white this out and say, look, okay, if I've got 2 fractions and I want to get those 2 terms into one term, well, then I would multiply this by the well-chosen one of 1 plus secant over 1 plus secant, multiply this by the well-chosen one of tan over tan, and now they both have the common denominator of tan times 1 plus secant. So this is going to give me tangent squared. And now if I multiply this binomial times this binomial, 1 times 1 is 1. 1 times secant is 1 secant. Secant times 1 is another one, so we have 2 secants. And then secant times secant is secant squared. So now that's my fraction, and I'm trying to get all the way down here to cosecant. So I just start changing things and see what helps. Well, I wish this was all one function. Well, this 1 plus tan squared I have memorized as secant squared. But then a secant squared plus a secant squared is 2 secant squareds. So then I wish I could cancel out this sucker, because maybe it's simpler. And I see that there's a 2 secant in both of these terms. So when I pull that out, 2 secant times what gives me 2 secant? Well, that's a 1. And then 2 secant times what gives me 2 secant squared? That would be a secant. Well, then that's beautiful because the 1 plus secants cancel out, and I'm left with this. And so now I'm here trying to get down to the end, and I go, okay, if I can get everything in terms of sine and cosine, maybe that's helpful. Well, this I have memorized as 1 over cosine. This is sine over cosine. Keep, change, flip gives me 1 over sine, then 2 over sine is 2 cosecant, and there was much rejoicing, right? Then 44, we are so almost done. Here, the main key was to remember that the sine of negative theta is the same as negative sine of theta, because sine is what's called an odd function. It's an odd function. That means that these negatives can pass through the function. So cosecant I rewrite as 1 over sine, and now I just have a bunch of sine of negative stuff. Well, this negative can pull out front here. This negative can pull out front here. And this negative pulls out front here to turn into a positive, right? But then I need to do this. I need to do this, take a screenshot, okay? And then if I hit, oh, it doesn't let me do that. Dude, let me try that one more time. Give me just a second. Boop, boop. There's one step in here that I really need to, let me just copy. So let me get this out of the way for you so you can really see what happens. So now that I've moved all those, I really want you to see that if you divide by negative sine squared, so if I take all this stuff and divide by negative sine squared, that's the same as taking all of this stuff, and instead of dividing by negative sine squared, I'm going to multiply by 1 over negative sine. And when you do, what's going to happen is that this times this gives you negative sine squared t, and this times this gives you negative 1. But then 1 over sine squared is cosecant squared, and cosecant squared minus 1 is cotangent squared, and there was much rejoicing. Keep on working, really. It's memorizing those trig identities, which makes it so easy to see things. You're going to do great. Talk to you soon.